Hello everyone, thank you for your interest in this presentation. My name is Sonik Patel, and I am the lead author and presenter for this study, 3 Environmental Imaginaries and Implications for Acceptable Energy Technologies in Alberta, Canada. I am a master's student in the Department of Resource Economics and Environmental Sociology at the University of Alberta, which is located on Treaty 6 land, the historic and present territory for many diverse Indigenous peoples of Canada. I am presenting this research on behalf of my co-authors Monique Hollowak, Dr. John Parkins, and Dr. Sven Anders. So this presentation covers a quantitative study of a survey that was completed in 2019. So I'll be presenting how we developed and conducted the analysis and the findings that we discovered. I'll start by briefly describing the context of Alberta, the location for this study. Alberta is a province in Canada which has jurisdictional control over energy production and transmission. In Alberta, generators are typically private firms that bid to sell power into the grid. About 90% of electricity produced in the province are from fossil fuel sources, and about half of that is from coal power, making it the largest coal fleet in Canada. Less than 10% of electricity is from renewable sources, and of these the largest source is wind, taking advantage of high wind speeds in the south of the province. If Canada is going to meet their carbon emission reduction targets, we need to develop more renewable energy, especially in a province like Alberta. While it seems that most Canadians are in favor of renewable development, there is a spatial component to this support that we need to consider. In Alberta, renewable technologies overwhelmingly locate on and impact rural agricultural land, while producing power for urban areas. Energy social science research has demonstrated that we need to understand the values, beliefs, and norms of people to understand support or opposition to renewable development. Canada has seen renewable projects be cancelled, and governments that are uninterested in supporting renewable development be elected because of substantial local opposition. And thus, in order to develop more renewable projects that embody energy justice in Alberta, we need to better understand the concerns of rural Albertans. This survey contributes to this understanding, and this paper focuses on one critical value that contributes to the acceptance of renewable power: environmentalism. This survey was put together by my colleague Monique and conducted in summer of 2019. The target population was rural landowners in Alberta, a population that is among some of the most affected by a renewable transition, as wind and, more recently, solar farms typically locate on rural farmland. The survey collected just over 400 responses, asking about energy preferences, environmental values, climate change concern, as well as numerous other opinions, values, and demographic details. You can see on this map where respondents are located, and the majority are in the southern, non-forested parts of the province, also the best locations for wind and solar development. Now let's look at the objectives of this study. This study focuses on how the value of environmentalism relates to support for renewable development. This relationship is less clear than we might expect, considering the environmental association that renewable energy often has. In energy literature, this is often called the green-on-green debate. Do environmental values predict support for renewable energy as a way to reduce greenhouse gas emissions to mitigate the climate crisis? Or do environmental impacts like avian fatalities, ecosystem fragmentation, and flooding from dams result in environmentalists taking an anti-renewable stance? This uncertainty in the literature calls for the need to have more precise and nuanced definitions of environmental values, or environmental imaginaries. Thus, the research objectives for this study are to see if we could identify different types of environmentalist attitudes in the sample, and to understand whether these more specific types of environmentalism are better able to predict support for renewable energy than the general encompassing term. So let's start by trying to identify these types of environmentalism. The survey asked 9 questions about environmental values and 4 about climate change values. As you can see, the variables asking about the veracity of climate change and the need for climate action are not strongly supported. The environmentalism variables had a low internal reliability score of 0.56, indicating that it is not a very consistent set of responses and justifying the need for more nuanced types of environmentalism. So we ran a principal component analysis, which placed these statements into 3 principal components: This is a statistical method that transforms a large set of variables into a smaller one. You can see which principal component each of these statements was placed into on the column on the right. The three scales we ended up with align quite closely with what we saw in our literature review. Here are the three environmental imaginaries that we found using the principal component analysis. Principal component 1 we called global environmentalism. This included all the climate change variables and the environmental variables that asked about global issues, like concern for anthropogenic impact on global environments, concern for plastic pollution and global species loss, and support for the need to protect the planet. Interestingly, this principal component also includes the measure for whether the respondent considers himself an environmentalist. Principal component 2 we called local environmentalism. The three variables in this scale focus on concern about impacts of the local environment. These include the statements, "My land is a big part of my identity," "I protect the health of my land to the best of my ability," and "I would be upset if my land was changed greatly." Principal component 3 we called farmer environmentalism because it relates to a phenomenon called the good farmer paradox. This describes an ideological paradox where farmers work on the land and thus consider environmentalism to be important, yet do not fully acknowledge the environmental impact of farming itself. How does this concept relate to renewable support? This is where analysis can get a little tricky. If renewable infrastructure is perceived as environmentally harmful, farmers are likely to oppose. However, renewable generation is not too different from agriculture farming, as they both involve extracting renewable resources from the land. And through this lens, farmers may believe that renewable energy generation is harmonious with the land like people believe farming is. Some researchers note that renewable opposition is stronger amongst people that view the landscape as idyllic and natural, whereas farmers understand the countryside can be a place of production. The statements within this scale include, "The wildlife on my property is as important as my crops or livestock, and my farming practices do not conflict with nature." Looking at the internal reliability score for these scales, global environmentalism is quite high, but local and farmer environmentalism are quite low. This might potentially be the result of the lower number of statements in these two scales, or that these types of environmentalism are not as present in the data, or they were poorly operationalized in the survey. However, we move forward with these scales as a reflection of the theoretical types of environmentalism that we found in our literature review. Let's now take a look at support for various energy developments that serves as the dependent variables in our analysis. The survey collected support for 5 energy types that are present in Alberta's energy landscape. As you can see from the descriptive statistics, oil from the oil sands is the most supported, followed by hydroelectricity, solar, coal, and wind is the least supported. The Likert scale that was used for this measure was converted into binary variables measuring support and not support, which was used as the dependent variables in our binary logistic regressions. So we created 2 models for each energy source. Model 1 used just the environmentalism scales as independent variables and energy support as the dependent variable, while Model 2 included several control variables, including demographics like age, gender, farm size, income from farms, and beliefs like political orientation, as well as opinions about the energy sector and community norms. Let's zoom in on the independent variables. So here are the models for our fossil fuel energy sources. For the oil sands, looking at the model with the controls, which is model 2, we have an R-square value of 0.38, and as expected, the global environmentalism scale significantly predicts opposition to oil sands development. For coal, again in model 2, we can see that global environmentalism predicts opposition to coal development, while local environmentalism predicts support. These results confirm what we might expect. Individuals that are concerned about global environmental impacts, including climate change, are likely to oppose greenhouse gas-intensive fossil fuel energy sources. Concern about local environmental impacts does appear to predict support for coal power. One potential explanation is that, although coal power does have significant local environmental impacts, they are less dispersed and therefore less likely to be near the respondent. Another possible explanation is that the environmental impacts of coal generation are not as well known or spoken about within the sample. Let's now take a look at our renewable sources. Starting with wind, Model 2 with the controls has an R-square value of 0.35. In this model, we can see that global environmentalism is a significant predictor of support, and somewhat surprisingly, local environmentalism is not a predictor of opposition. We see similar results for solar, which is on the right. In Model 2 with an R-square value of 0.45, global environmentalism is a significant predictor for support, while both local and farmer environmentalism are not significant. And finally, hydroelectricity. Despite having few projects built recently or in development, hydroelectricity is still a significant source of renewable energy in Alberta, due to legacy hydro dam projects. In Model 2, with an R-square value of 0.23, both farmer and local environmentalism are significant predictors of opposition to hydropower. We can see that global environmentalism, our most reliable scale, unsurprisingly predicts support for solar and wind development, but not for hydroelectricity. This might be potentially because hydro dams have the highest environmental damage of these renewable technologies. The global environmentalism scale appears to have big stability to predict whether respondents consider this environmental damage an acceptable trade-off for carbon-neutral energy production. However, high scores on the local and farmer environmentalist scale does predict opposition to hydroelectric development. Understandable, considering the high environmental damage, without considering the trade-off for greenhouse gas emissions reduction. Interestingly, local environmentalism is not a predictor for opposition to wind and solar projects, challenging the green-on-green debate. They also do not predict support for renewables either. So, to summarize what we saw in the models, confirming our expectations, the models constructed show that global environmentalism significantly predicts opposition to fossil fuel development, while predicting support for wind and solar. Local environmentalism was insignificant in predicting opposition to wind and solar, but did predict opposition to hydroelectric development, which is understandable as it is the most environmentally harmful of these renewable technologies. And farmer environmentalism was our most unpredictable scale from a theoretical perspective, as the good farmer ideology could explain both support or opposition to renewable development. The models confirm this ambiguity, as the scale was only significant in predicting opposition to hydroelectric development. So what can we take away from this analysis? Environmentalism is often cited as one of the benefits and reasons to support renewable development. However, the low internal reliability of the environmental values in this survey reveals the need to identify more nuanced definitions of environmentalism. We constructed 3 scales, reflecting themes from energy sociology research. Of the scales, only global environmentalism had a high internal reliability, while the local and farmer environmental scales had weaker reliability, but also fewer measures. What are the implications for renewable development in Alberta? Well, the study shows that global environmentalism is a significant predictor for renewable support, and proponents need to place a greater emphasis on demonstrating the importance of addressing climate change. This is a challenging proposition, as the sample demonstrated low to mixed belief in the need for climate action, and it also requires greater institutional supports. The study also shows that local environmental concerns are not a significant reason to oppose wind and solar development, which is a good thing for renewable development in Alberta because these values are quite high in the sample. Proponents do need to do a better job communicating the environmental performance of renewable infrastructure, particularly wind and solar, both of which are being pursued as the renewable solutions for Alberta. So while these technologies do have environmental impacts, the sample appears to overestimate what these impacts may be. And because of the low internal reliability of the scales from this study, more work is needed to identify the presence and validity of environmental imaginaries, both explored here and other types of environmentalism that can better explain complex environmental behavior like renewable support or opposition, which is crucial to understand to develop methods to foster renewable development. If you are interested in seeing more results from this survey, we recently published a project report available on the University of Alberta's webpage for the Department of Resource Economics and Environmental Sociology, and is also linked on this slide. So thank you very much for your time and attention, and I would now like to invite any questions.